let's take a moment to visualize our body without joints. The truth is, we would have been no better than a pool. But thankfully, we all have joints in our body. Let's talk more about joints. I am Ofrim Chukwudi, and I welcome you to this interesting physical and health education class, where I will be discussing a theme: basic human anatomy and physiology in relation to physical activities. And our topic of interest remains the skeletal system. By the end of this lesson, you should be able to mention the types of joints and list the joints that cause the different kinds of movement. As humans, we all have to achieve different levels of movement, such as walking, running, writing, speaking, and even bending. To make movement possible, the bones need not be fused together, because if they are all fused together, no form of movement will be possible. The joints are found between bones to allow for different degree of movement, while also connecting all bones together as a single unit. But what is a joint? A joint is an area in which one or more bones are connected together. A simple graphical representation of a joint is found on the board. Here we see one bone and another bone. This area in which they are connected together is what we refer to as a joint. Joints exist for several reasons, predominant among which are to allow for movement and to provide stability. In the human body, there are different types of joints, as we'll find out. Based on their structure and the level of movement they allow, there are three basic types of joints in the human body, namely the fibrous joints, the cartilaginous joints, and the synovial joints. Take note, the fibrous joints are also referred to as the immovable joints, while the cartilaginous joints are referred to as slightly movable joints, and the synovial joints are referred to as freely movable joints. Now let's talk about fibrous joints. As the name implies, fibrous joints are joints which are connected by strong fibrous tissue, usually called a collagen. They allow for very little or no movement at all. And common examples include the suture, which are narrow joints found between the bones of the skull. Another common example of a fibrous joint is a special joint that holds the tooth in place with its socket in both the lower and upper jaw, known as the gum fusses. Next, let's talk about cartilaginous joints. In a cartilaginous joint, bones are held together by means of cartilages, which are tough and elastic tissues which help reduce friction between bones. They are elastic and more flexible, and for this reason, they allow for relatively more degree of movement compared to fibrous joints. Common examples of cartilaginous joints are the joint between the hip bones, as well as the joint found between the bones of the vertebral column. And finally, another common example of a cartilaginous joint is the joint found between the bones of the ribs and the sternum. Next, we'll talk about synovial joints. Synovial joints are freely movable joints. In a synovial joint, bones are connected in a synovial cavity, which is a space formed between two or more bones. This allows for different degree of movement. Because of the nature of synovial joints, a special fluid can be found in them, which is called a synovial fluid. This synovial fluid helps reduce friction between the bones while lubricating the joints. Going forward, our focus will be on synovial joints since they are implicated in most human movement. Now let's talk about the features of a synovial joint. Synovial joints are the joints in which bones are not directly connected together. All synovial joints have the following features. 1. There's a joint cavity, which we know as a synovial cavity. Then, there's an articular capsule and the articular cartilage. Let's talk about the joint cavity. The joint cavity is a space found between bones in a synovial joint, which allows bones to move freely and prevent friction, which can subsequently cause damage to the bones. Contained in the synovial cavity is a special fluid or a liquid which aids to lubricate the joints, provide nutrients to the cartilages, and aid in shock absorption. Another important feature of a synovial joint is the presence of an articular cartilage, which is a special cartilage layer attached to the end of each bone in a synovial joint. This layer helps to reduce friction and absorb shock. Finally, the articular capsule. The articular capsule is a group of special tissues that surround the synovial joint to provide support and secrete synovial fluid. Having discussed about the different features of a synovial joint, now let's talk about the different types of synovial joints. Remember, synovial joints are the joints which are implicated in different human movements. They are found in different parts of the body, and each type of synovial joint allows for different type of movement. There are 6 common synovial joints in the human body, namely the ball and socket joint, the hinge joint, the pivot joint, the saddle joint, the condyloid joint, and the planar, plane, or gliding joint. Before talking in detail about each of these synovial joints, it is important to note that each one of them performs unique functions in relation to movement. That's why I want to talk briefly about some movement terms we may come across in the course of this lesson. First, flexion and extension. The first movement term we'll be talking about is flexion and extension. Flexion and extension are movements of the body which reduces or increases the angle of a body part. Generally, a flexion and extension will affect the angle of one or more body parts. For example, in flexing the elbow, you reduce the angle between the bones of the lower arm and the upper arm, while in extending the elbow, we increase the angle between both bones. Another movement term of interest is rotation. Rotation is a circular movement of a body part, resulting in a change in direction of that body part. For example, rotation of the neck sideways, as well as rotation of the arms. In both instances, notice that there is a change in direction of the palm and the face. Another movement term of interest is abduction and adduction. Abduction is the movement of a body part away from the body's midline. For example, the abduction of the arm means that you are moving the arm sideways away from the body. An abduction of the leg means moving the leg sideways away from the body midline. Adduction is the opposite of abduction, in which there is a movement of a body part towards the body's midline. And finally, let's talk about circumduction. Circumduction is the movement of a body part in a circular motion, which usually results in the formation of an imaginary cone. In circumduction, the circular movement does not result to the change in direction of the body parts. It is just an upward, downward, sideward movement of one or more body parts. For example, the circumduction of the arm should look exactly like this. Notice that the direction of the palm remains facing forward without tilting sideways or upwards. That's an example of circumduction. Having considered the different terms of movement, now let's talk about the different types of synovial joints. First, we'll talk about the ball and socket joint. In a ball and socket joint, a round ball-like end of a bone fits into a cup-like end of another bone. A common example is the shoulder joint, which is a joint found between the humerus and the shoulder blade. Another common example is a hip joint, found between the femur and the pelvic. The ball and socket joints allow for movement in all directions, which are flexion, extension, adduction, abduction, circumduction, and rotation. Next, we'll talk about the planar joints. Planar joints are also known as plane or gliding joints, and they are so designed so that bones are allowed to glide over each other, since the bones have relatively flat surfaces. Common examples of planar joints include the acromioclavicular joint found between the scapula and clavicle, the intercarpal joint found between the bones of the wrist, as well as the intertarsal joint found between the bones of the ankle. The plantar joints allow for limited movements, namely extension, flexion, and slight rotation. By slight rotation, we mean rotation within one axis. Next, the saddle joints. Think of a saddle joint like a horse and its rider. In a saddle joint, a bone with a concave surface fits into another bone with a convex surface. Common example is demonstrated in the board here. The concave bone, which is the bone that is curved inward, fits into the convex bone, which is the bone curved outwards. And common example includes the carpometacarpal joint, found between the wrist bones and the bones of the palms. Another common example is the sternoclavicular joint, which is found between the bones of the sternum and the bones of the clavicle, which is the collarbone. The saddle joints allow for different forms of movement, including flexion, extension, adduction, abduction, and circumduction. Next, we'll talk about the hinge joints. Think of a hinge joint like a door. In a hinge joint, a bone has a hammer shape and it fits into another bone with a hollow end. For this reason, one bone can move while the other remains stationary, just like a door. Common examples of hinge joints include the elbow joint and the knee joint. Hinge joints allow for movements only along a plane, and movements allowed are flexion and extension. Next, let's talk about pivot joints. In a pivot joint, a cylindrical bone fits inside another bone which forms a ring around it. This structure allows the bone to rotate within itself. A common example of a pivot joint is the atlantoaxial joint, which is found around the neck to allow for movement of the head. Another example is the radio-ulnar joint, found between the bones of the radius and ulna to allow for movement of the lower arm. The pivot joints allow for limited rotational movements. And finally, let's talk about the condyloid joints. Condyloid joints exist between bones with oval surfaces. One bone with an oval surface fits into another bone that also have an oval surface. A common example of condyloid joint is the wrist joint, found between the radius bone and the carpals. Another common example is the metacarpophalangeal joint, found between the bones of the phalanges and the metacarpals. And another common example is the metatarsophalangeal joint, found between bones of the metatarsals and the phalanges of the foot. Condyloid joints allow for flexion, extension, circumduction, abduction, and adduction. Having discussed about the different types of joints and the movement they allow, we have come to the end of this class. But before we go, let's take a quick summary of what we've learned so far. First, we learned that a joint is an area where two or more bones are connected together. Next, we learned that there are three common types of joints, namely the fibrous joints, which are immovable joints, cartilaginous joints, which are slightly movable joints, and synovial joints, which are freely movable joints. Also, we learned that synovial joints are freely movable joints, which allows for different degrees of movement. And finally, we learned that there are 6 types of synovial joints, namely ball and socket joints, hinge joints, saddle joints, planar joints, condyloid joints, and pivot joints. Now, we'll be having some test questions to see how much we've learned so far in today's class. Question 1. Which of these joints is a fibrous joint? Is it A, gomphosis, B, hinge joints, C, radio-ulnar joint, or D, elbow joint? The correct answer is option A, gomphosis. Question 2. Which movement is unique to the ball and socket joint, saddle joint, and condyloid joint? Is it A, flexion, B. Extension, C. Adduction, or D. Circumduction? The correct answer is D. Circumduction. Here is where we draw the curtain for this lesson. I hope you can now mention the different types of joints as well as the joints responsible for different types of movement. We'll meet in my next class. Bye for now.